Okay, in this video, let's go through a few more examples of implicit differentiation. And the first example I'll take is, let's say we are given x squared, y squared equals x plus y. And I want to find, once again, I want to find what dy over dx is. Differentiating both sides with respect to x. Now remember, this here is a product rule again. So I have u times, I take that as my u and v. So I have u times dv over dx. So u is equal to x squared times the derivative of the second. So the derivative of y squared will be 2y. But since I'm differentiating y with respect to x, I would get 2y dy over dx. It's 2y dy over dx. Then I've got plus the second function times the derivative of the first. So that gives y squared times 2x. And that would be equal to, differentiating the right hand side, I would get 1 plus differentiating the y term, that gives 1 dy over dx. Or I could just write that as dy over dx. And if you want to make dy over dx the subject, then you would get 2x squared y dy over dx. Bring this dy over dx term to the left hand side, so that becomes minus dy over dx. And that's equal to 1 minus this term here, that would give 2xy squared. That's bringing this term to the right hand side. Now dy over dx is a common factor. I can think of this as 1 dy over dx. So dy over dx times 2x squared y minus 1 is equal to 1 minus 2xy squared, or dy over dx is equal to 1 minus 2xy squared divided by this term here, that gives 2x squared y minus 1. Okay, let's now take an example that involves the chain rule as well. So let's say we have something like x plus y to the power 4 is equal to 4x plus 4y. I'll make that 4x plus 5y. Okay, now the left hand side, now the right hand side is quite easy to differentiate, but the left hand side you got to use the chain rule. And we said if we have some function raised to the power of a constant, then the derivative of that will be 4 times the function, leave the function as it is, so that's x plus y, reduce the power by 1, so I have 4 times x plus y to the power 3 times the derivative of the inside part. So the derivative of x plus y would be 1 plus dy over dx. The derivative of x with respect to x is 1. The derivative of y with respect to x, that's dy over dx. And differentiating the right hand side with respect to x gives 4 plus 5 times dy over dx. But now to make dy over dx the subject, what I'm going to do is expand this bracket on the left hand side. I'm going to multiply this term here with these two terms on this bracket. So that gives 4 times x plus y cubed. That's this term times the 1. Then I have this term times the dy over dx. So that gives 4 times x plus y cubed times dy over dx. And that is equal to 4 plus 5 dy over dx. Okay, and then I can take all dy over dx terms to the left hand side, so that I have 4 times x plus y cubed times dy over dx minus 5 dy over dx is equal to 4 minus, bring this term to the right hand side to give minus 4 x plus y cubed. Dy over dx is a common factor again, so I'll take that term out. So dy over dx would be equal to, dy over dx times, I have 4x plus y cubed minus 5 is equal to 4 minus 4 times x plus y cubed. So that gives dy over dx equal to 4 minus 4 times x plus y cubed divided by this term over here. So that's 4 times x plus y cubed minus 5. Okay, let's take one last example involving the ln function as well. So let's say we have ln of x plus y. Let's take ln of x plus y is equal to x squared plus y squared. Once again, I want to find dy over dx. I want to find dy over dx. And differentiating the ln function, we see that gives 1 divided by that same function, so that's x plus y. And then I got to multiply it by the derivative of the inside part. Now the derivative of x plus y, the derivative of x is 1, the derivative of y with respect to x, that gives dy over dx. And that's equal to differentiating the right hand side. I get differentiating x squared with respect to x, that's 2x. Differentiating y squared with respect to x, that gives 2y dy over dx. Okay, now once again, if I want to make dy over dx a subject, then I'm going to multiply this term here with these two terms in this bracket, so that I have 1 over x plus y times 1, that gives 1 over x plus y. Then I've got plus 1 over x plus y times dy over dx, so that gives 1 over x plus y times dy over dx. And that's equal to 2x. That's equal to 2x plus 2y dy over dx. Okay, now to make dy over dx a subject, I'll bring all dy over dx terms to the left hand side. So that gives 1 over x plus y times dy over dx minus 2y dy over dx, and that's equal to 2x minus 1 over x plus y. And I've just taken this 1 over x plus y term to the right hand side. And let's work on the right hand side term first. If I want to make x plus y the common denominator, I have to multiply this term by another x plus y, so that this becomes 2x squared y over x plus y. Oh no, that doesn't work, sorry. That should be 2x times x plus y. That would be 2x times x plus y over x plus y. So all I've done is just multiplied the numerator and the denominator by the x plus y term. Now on the left hand side, I can take dy over dx as a constant and then rewrite the inside part as I have 1 over x plus y minus 2y. And just like I did on the right hand side, I want to make x plus y the common denominator, so I'll multiply the numerator by x plus y as well. So now I get that's equal to, so this gives 2x squared plus 2xy minus 1 divided by x plus y. And this inside part here, I could write this over one common denominator and just get rid of that x plus y, because x plus y is a common denominator for these two terms. But since I have x plus y in both the denominators on both sides, I can cancel these two terms out. So this gives me dy over dx times, multiplying this bracket out, I get 1 minus 2xy minus 2y squared is equal to 2x squared plus 2xy minus 1. So dy over dx would be equal to, on the numerator I have 2x squared plus 2xy minus 1, divided by bringing this term over to the right hand side. I divide that by 1 minus 2xy minus 2y squared.